Hello students and welcome to the lecture. So students, as you can see here, basically in this lecture, we are going to start our discussion over the motion. Okay. And that is going to be our part 1. In this lecture, basically, we will look at the introduction of motion because first we are required to understand that what is a motion exactly. Then only we will be able to proceed further and try to get some new points. Okay. Then we will talk about the motion and rest. Thereafter, motion in 1, 2, and the 3 dimension. And at last, we will see the summary of all of these. Okay. But as usual, before starting this lecture, we have a small disclaimer over here that we are required to understood first. So a disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the image. Now, let's start our journey with the introduction. So basically, in physics, there is a branch. Branch means that there is a particular discipline to study. There is a branch of physics which deals with the study of motion of material objects. Is called the mechanics. So in formal way, if someone asks you like, what do you mean by the mechanics? So instead of thinking about the mechanic shops that you see usually, just think about the definition that we have covered right now. The branch of physics which actually deals with the study of motion of material object is called the mechanics. Like whatsoever material object you see around yourself, is these objects moves or in the motion, then that will be a motion, or you can say movement, and that will be dealt by the mechanics. Got it? Mechanics could also be broadly classified into the 2 following branches, and these branches are: first, statics branch. It is a branch of mechanics which deals with the study of material object at rest. Secondly, kinematics. It is that branch of mechanics which deals with the study of motion of material objects without taking into account of vectors, nature of force, nature of bodies, etc. So like you can say in mechanics, we actually talk about the motion and the rest of any material object. If there is any material object that we see, if that object it is rest, okay, that object is not moving, that will be a part of mechanics in the sub-branch statics. Because right now that object is not in the motion. Another one, if that object is moving, then that will be studied under motions sub-branch, under mechanics sub-branch kinematics. Okay. Remember this. Here, time factor plays an essential role. Like we could say, without taking into account of the factors like nature of force, nature of bodies, we do not take them in account while we talk about the kinematics. But time factor, yes, we do take it into the consideration. There is an important note. The term kinematics is actually derived from a Greek word kinema. Okay. And this kinema actually meaning a motion. Got it? Then dynamics, third branch. It is that branch of mechanics which deals with the study of motion of objects taking into account the factor which cause motion. Okay. Like you can say, when we just not only looking at the object which is moving, but we are trying to find out or we are trying to figure it out why this object is moving, then it will be studied under dynamics. Okay, because right now you are not only looking for the motion in any object, but you are also taking consideration that why this object is moving. What is the factor that cause the motion exactly? Here, Also, the time factor plays an essential role. Since the force is the cause of motion, therefore, dynamics is based on the concept of force. Okay? Like you can say, if any object is at rest, until or unless you exert any kind of force on that particular object, that object will not move, right? So that's why we generally know that force is the cause of motion. Therefore, dynamics is actually the concept of force. Got it? Now, motion and rest. So far, I hope you have understood the difference between the rest and motion. Okay? Even if you look at this picture, what you're seeing? You're seeing the buildings, this air traffic control tower, tree, house. So if you passing by some house, okay, the place where you have seen it, next day you will again see the house on the same place. What does it mean? It means that house in respect of its surrounding not moving or not in a motion. That house is in the same place where it was on yesterday, where it is today, where it will be tomorrow, until or unless that got demolished or any kind of other thing. Okay. But here, if you're seeing that there is a parrot or there is a bird or there is a man. Now, suppose you are walking on the road, you saw someone is jogging beside you or someone is running beside you. So if you had seen that yesterday, will you see that the same thing today? No. Why? Because that particular thing, for example, that particular person was in the motion in relation with its surrounding, right? So that is the former difference between the rest and the motion. The concept of motion and rest actually depends on observer, which we call as a frame of reference and object. Okay. If the position of an object in space changes with time related to an observer, it is said to be in motion. Like you can say, for example, if this is an object that you are seeing, all right. So, or you can say, basically there is a change considered. Then you can say this is an object that you have changed. Now you are standing beside him. So you will see this person will not be at the static position. Maybe this person start from here, then he's here, then he is here, then he is here. You are still at the same place, right? So now you can say, basically in reference of you, that particular object is changing its position. Then you can say that object is in the motion. Okay. In the another scenario, if this is your position or you are the frame of reference and you had seen the object here. After a passage of time, after a period of time, that same object is at the same place. The object is not changing its position. What does it mean? It means the object is not in a motion. Got it? Or at rest. Now the dimensions or the linear motion, 2 dimensions, planar motion, or then the 3 dimension. Got it? Broadly, the motion could be maintained into the following 3 types. First is rectilinear and translatory motion. So we could say if a particle or body treated as a point is moving along a straight line, the motion is called rectangular. Okay. We could say if this is any particle or a body, now this is moving in the straight line, changing its position with the reference. But in the straight line, that will be a rectilinear and translatory motion. However, if the body couldn't be treated as a point but moves in such a way that all its particles move simultaneously along straight lines, which are collinear are parallel to each other by shifting through equal distance in a given time, the motion of the body is called translatory. Okay? Remember, if a body is moving in the straight line, rectilinear, if body couldn't be treated as a point but moves in such a way that all its particles, we are saying this, move simultaneously along straight lines, which are collinear or parallel to each other by shifting through equal distance in a given time, then the motion of the body is called translatory motion. Okay? Then a body sweeping along the inclined plane has also the translatory motion. Rectilinear and translatory motion could be uniform or non-uniform. What do you mean by the uniform? And what do we mean by the non-uniform? Let me give you a one simple explanation, because we will talk about them, uniform, non-uniform, in our upcoming lectures. But right now, I could just give you an overview. Like you can say, if this is the point of reference, and if the object is changing its position, so amount of changing the position and the time taking while changing the position, they both are same. Again, I'm saying, if the amount of changing the position or the time taking while changing the position both are same, then that will be a uniform motion. Okay? On the contrary, if the amount of changing the motion and the time taken while changing the motion, they both are different, then they will be a non-uniform motion. Okay? So far, you are only required to keep this in your mind, because as I have told you, we would look at this point in detail in the upcoming lectures. Till then, just know, if in respect with the point of reference, the change in the motion is same in the changing time, uniform motion. If change in the motion and time taken while changing the motion, they both are different, then non-uniform. Okay? Thereafter, the circular and rotatory motion. What do you mean by this? If a particle or body treated as a point is moving on a circle, the motion is called circle. Okay? Like you can say, if this is the point and the body is revolving around it or changing its position in reference to this circulatory term, then that will be called as a circular motion. However, if the body couldn't be treated as a point and all its particles move simultaneously along circles whose centers lie on a line called axis of rotation by shifting through equal angle in given time, the motion is called rotatory motion. Okay? It is 2D or 3D motion and could be uniform or non-uniform motion both. It is uniform, it is periodic. Thereafter, the oscillatory and vibratory motion. If a periodic motion is constrained, okay, therefore, within certain limits, or is to and fro or up and down, it is said to be oscillatory. If in case of oscillatory motion, amplitude is microscopic, it is usually said to be vibratory motion. If it is not microscopic, that will be oscillatory, but if microscopic, that will be a vibratory. In the oscillatory or vibratory motion, if the restoring force or torque, remember, restoring force or torque is linear, the motion of the body is said to be simple harmonic motion. There is a note. An object could be considered as point object if during motion in a given time, it covers distance much greater than its own size. Then it is It is important to note that the point object is mathematical concept to simplify the problem. Okay. Now it's for a time for motion in 1, 2, and 3 dimensions. First is one-dimensional motion. The motion of an object is said to be one-dimensional motion if only one out of 3 coordinates specify the position of the object changes with respect to time or when a body moves along a straight line path. Its motion is said to be the one-dimensional motion. Like here, you can see. Okay. This is an example of this. One-dimensional motion is sometimes known as the rectilinear or linear motion also. For example, the motion of a train on a straight track, a stone falling down vertically, or car moving on a long and straight road, etc. These are the one-dimensional because only they are moving in the straight or only in the one coordinate out of the 3. Now, two-dimensional motion. Suppose an object is moving on xy plane with origin at 0, like this one. This is the x, this is the y, and it has been originated from here. Now you can say it is supposed to go there and it is also supposed to come here. Like at the same time, it is moving on the 2 coordinate. At time t, let the object be at P. Okay. Then whose coordinates be x, y. It means to know the position of the object moving in xy plane at a given time t. We are required to know the 2 coordinates. Therefore, distance along x-axis and y-axis. Such a motion of an object in which 2 coordinates are changing with time is called two-dimensional motion. Thus, the motion of an object is said to be two-dimensional motion if 2 out of 3 coordinates specifying the position of an object change with respect to time. In two-dimensional motion, the object moves in a plane. For example, the earth revolving around the sun, a billiards ball moving over the billiards table, etc. Now the three-dimensional motion. Suppose an object moving in space having the 3 mutually perpendicular axes which are labeled as x, y, and z axis. They had their origin at 0, figure t. At time t, let the object be at P whose coordinates be x, y, z. It means to know the position of the object in space at a given time. We are required to know 3 coordinated, therefore distance along x, y, and z axis. Okay. Such a motion of an object in which 3 coordinates are changing with time is called the three-dimensional motion. So remember, in the one-dimensional, only the 1 out of 3 coordinates changing position with time. Two-dimensional, 2 out of 3 coordinates changing position with time. In three-dimensional, all the 3 coordinates changing with time. Okay. Thus, the motion of an object is said to be the three-dimensional motion if all 3 coordinates specifying the position of the object change with respect to time. In three-dimensional motion, the object moves in space. Okay. For example, a flying aeroplane or bird, the random motion of a gas molecule, etc. So here we had finished the topic, not part for the summary discussion. We have talked about the mechanics, which is the branch of physics that studies the motion of material object, divided into the several branches that we have covered, like statics, focus on object at rest. Kinematics studies the motion of objects without considering the forces causing the motion. Time is a crucial factor here. Dynamics examine the motion of objects while considering the forces causing the motion. Time and force are essential factors here. Motion could be classified based on dimensions, as we know. One-dimensional motion, two-dimensional motion, three-dimensional motion. Types of motion include like rectangular and translatory motion, circular and rotatory motion, oscillatory and vibratory motions, and then other things. So with this, we have finished this part. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, Let's end this lecture and thank you.